So geometry and algebra, they are very closely connected. And one problem from CMI 2010 is a very good example of this connection, this relationship. So today we will do this problem. You can grab a pen and paper and walk with me through this one. Okay. This problem says that we have a sequence A1, A2, AN, which is also in arithmetic progression. And we want to show that, so if you think of A1, B1 as a point, A2, B2 as another point, and so on, these are all collinear, that they lie on the same straight line. So before we start, let me quickly tell you what is an arithmetic progression. Maybe you already know this. An arithmetic progression is, I showed you by an example, 3, 5, 7, 9, and so on. This is an example of an arithmetic progression. And then there is a common difference. In this case, this common difference is 2. If you check, the difference of any two consecutive terms is 2 in this particular example. So algebraically, we can write it as, if this common difference is D, we can write the sequence as A plus D, which is A plus 2D, A plus 3D, and so on. That's how we can describe algebraically an arithmetic progression. So now let's get back to this sequence. We have two arithmetic progressions, A1, A2 up to AN, B1, B2 up to Bn. Let me write this in that form that I just told you, okay? So the first sequence is A1, A2 up to AN. So this one is A1, I'll just call it A1, the first term. The second term is A1 plus some B1. B1 is the common difference of this first arithmetic progression. Similarly, A3 would be A1 plus 2B1 and so on, right? Okay, so what we will do is, we will show that these constitute collinear points. So for that, you will need another concept, the concept of a slope. How do you show that points are collinear? Well, one way is that if you can show that their slope is same. So A1, B1 and A2, B2, that the slope of the line joining A2, B2 and A3, B3 is the same, then you will be done. Why? Well, to do that, you will have to sort of review a bit of coordinate geometry. Slope tells you about the rise over run of a particular straight line, how fast it is rising per unit movement along x-axis. So if that is equal over two intervals, then those two intervals are part of the same straight line. This is just a sort of a brief description of what it is, but you can go to any coordinate geometry book and look into it. So what is the slope? The slope of 2 points, maybe if I can write it here, if I have x1, y1 and x2, y2 as 2 points, then their slope is y2 minus y1 divided by x2 minus x1. This is the change in y, or the height, the rise, and this is the change in x. That is the run. Okay. So now let's calculate what is this rise over run in this particular. So in this first interval, we have the slope is b2 minus b1 by a2 minus a1. So b2 minus b1 is divided by the common difference of the first progression. Can you calculate the slope of this second point to second point, that segment, and tell me what is the slope in the comment section? There is something very nice about this problem. It tells you that if the points are collinear, if the points are in arithmetic progression, if the first coordinates are in arithmetic progression and the second coordinates are in arithmetic progression, then the points lie on the same straight line if you visualize them on the coordinate plane. Very nice connection between geometry and algebra. If you do not know about Chennai Mathematical Institute, you can Google it. You can find more about it. It's one of the best places to learn mathematics in India. Check the link in the description for our open WhatsApp group on ISI and CMI entrances. Chinta provides outstanding programs on ISI-CMI Entrances, Mathematics Olympiads, Physics Olympiad, Informatics Olympiad, and Research. If you want to know more about it, you can go in the link. Thank you for watching this video. I will see you in the next one.